Well, ladies and gentlemen, really inspiring speech. Next, we would like to invite the next speakers for our special topic. So the topic is about mass extinctions with geologic time. Mr. Keng Lok is a long-time Mensa member since 1989. That is 34 years ago. Since he became a Mensa, he has held every position in Malaysian Mensa, including 4 years as its chairman. At the international level, he has been and still is a member of the International Election Committee for 3 elections. He is a very strong supporter of the AMG and has attended 7 out of the 10 of them. Keng Lok has been a geologist for more than 40 years in the private sectors and academia, and he is sharing his first experience in geology by speaking on a subject that is not related to AI, theme of this talk, but something very interesting and intriguing. Well, ladies and gentlemen, please welcome Mr. Keng Lok.
Thank you for the introduction. Good morning, everyone. I think all of us here know that there are no more dinosaurs alive today. But do we know when did they disappear? And what caused their extinction? With that in mind, let's run through geologic time from the time that Earth was formed 4.6 billion years ago till present time, and find out more about mass extinctions within geologic time. Next slide. The Earth's history is divided into sections of time. How many years ago? And it is based on the fossil evidence, fossils and rocks evidence. It is used to describe the timing and relationships in geologic history. Mass extinction is a sharp spike in the rate of extinction of species caused by one or more catastrophic event and or rapid environmental change. Scientists have identified there are 5 mass extinctions over the geological time scale, and each one of them had led to a loss of more than 70% of animal life. The geologic time scale is the calendar of events in Earth's history, and it is based on stratigraphy. What is stratigraphy? Stratigraphy is the correlation and classification of rock strata or rock formations and the fossils found in them. This fossil record, though patchy and incomplete, is found all over the world and is studied in great detail. These rocks and fossils are products of a long and complicated history. Initially, the age of rocks are given names like Permian and Jurassic. I think most of you have heard of this word called Jurassic. When radioisotopes were discovered and radiometric dating was invented in the early 20th century, it gave the age in years. So these are the MYA, million years ago. Okay? The largest scale is the Eon. There are 2 of them, Precambrian and the Phanerozoic. The Precambrian is divided into three eras: Hadean, Archean, Proterozoic, and the eras are divided into periods. So this is from this Phanerozoic. More action and more things happen during the Phanerozoic in life form than the Precambrian. The three eras: Paleozoic, Mesozoic, Cenozoic. And the Paleozoic has got 6 periods: Cambrian, Ordovician, Silurian, Devonian, Carboniferous, Permian. And the Mesozoic has 3: Triassic, Jurassic, Cretaceous. And the Cenozoic has 2: Tertiary and Quaternary. Okay, maybe not enough time to tell you which species appear when. So I'll just point out some major ones. Cambrian, okay, because earlier when when the first life form began, it was somewhere around here. Okay, when the crust is formed, that is where the land is found. Okay, then life begins in the sea. Single cell animals went into multi-cell animals, so it's like algae, bacteria, and all that. But into the Paleozoic, then chordates appear. That's the animal with backbone. Then the first fish. Then there was major diversification of animal life. A lot of animals living here. Okay, Silurian, there was the first vascular plants. And then Devonian, first amphibians, fish diversity, a lot of fishes living. These are all still living under the sea. And Carboniferous, the first reptiles, trees, seed ferns. And the Permian, there was a major extinction and reptiles diversified. Okay, but in Triassic, the first mammals and the first dinosaurs appear on Earth. And then in the Jurassic, the dinosaurs diversify. Then the first birds, the first flowering plants were here. The first primates, extinction of the dinosaurs in the Cenozoic. And the Tertiary, when mammals diversify into what you see now. Okay, there are five mass extinction, like I mentioned earlier. So the first one is here, marks the boundary of Ordovician and Silurian. The second one is Devonian, Carboniferous. The third one is a major one between Permian and Triassic. It is also between the Paleozoic and the Mesozoic era, right? And then the fifth one is 65 million years ago, that is here, right, between the Cretaceous and the Tertiary, and also between the Mesozoic and Cenozoic. Okay, let's get straight into it. All right. The first, like I said earlier, Ordovician Silurian is 440 million years ago, 85% extinct. The second one was 365 million years ago, 70% extinct. The third one was 250 million years ago, 95% extinct. So this is the major one. And then it went into the Triassic, Jurassic boundary, 200 million years ago, and 65 million years ago, 70% extinct, and this is 75% extinct. Okay, let's get to a bit more of it. All right, this is the first one. This first extinction happened about 440 million years ago, when there was a major ice age, a glaciation event, followed by a sudden warming and heating event. The effect of these changes to the climate was devastating, where 85% of species went extinct. Creatures that had adapted to the cooler climate were unable to survive the increased temperatures, resulting in their deaths. Luckily, not everything died out. These are some of the animals that were affected: the trilobites, the brachiopods, the bryozoans, the enoderms, and graptolites. These are all living under the sea. Okay, luckily not everything died out, and among the survivors were some of the armored chordates, that's the animals with backbone. So during the periods of Silurian and Devonian, which is after the first one, these chordates evolved into different forms, leading to the diversification of fishes. I'm going a bit fast because they gave me 50 minutes only. Okay, this is the second one, which is in the Devonian and Carboniferous. All right, then came the second extinction, which is this one. Okay, the second one. Okay, so what happened here is that towards the end of the Devonian, there were many environmental changes. One theory suggests that when the land plants flourish, this is the time when plants have gone on land, continents already forming. A large amount of nutrients were released into the sea that fed algae to develop into very large algae booms that consume vast amounts of oxygen, suffocating many species. Another theory suggests a global warming event that resulted in glaciation and a fall in the sea level, leading to habitat loss that resulted in 70% of all marine species becoming extinct. The third one, before this third mass extinction, there was a flourish of land plants which provided nutrients and led to an abundance of land animals. They thrive very well as maybe here. Should tell me earlier. This side more handsome. Before the third mass extinction, there was a flourish of land plants which provided nutrients and led to an abundance of land animals. They all thrived very well as the climate was very conducive then. And also at this time, a supercontinent, maybe this is a new word that you all will learn, a supercontinent called Pangaea was already formed, stretching from the north to the south pole. Pangaea was inhabited by a wide diversity of animals. Once you have continents, then you have land plants and land animals. They move on land. Okay? But by the end of the Permian, about 250 million years ago, disaster struck, which brought the worst extinction crisis in Earth's history, bringing the Permian to an end, with about 95% of all species lost. This third mass extinction is often referred to as the Great Dying. So what caused it? This mass extinction coincided with a big increase in volcanic activity in a huge area now known as Siberia, spewing huge quantities of molten lava flowing over large stretches of land, killing everything in its path. It also caused huge amounts of methane and carbon dioxide into the atmosphere. Both are greenhouse gases, which led to a dramatic rise in the Earth's temperature and triggered this third mass extinction in which 95% of all species were lost. Okay, the fourth one. However, even though there's extinction, the world recovered. Usually it takes about 10 million years for species to diversify again. Okay, the world recovered after the Great Dying. The following 50 million years during the Triassic, new species evolved from the survivors, replacing many of those that were lost. Mammals and dinosaurs first appeared during this period. But this situation changed towards the end of the Triassic. About 200 million years ago, there was another mass extinction, the fourth one. Massive volcanic eruptions occur as the supercontinent Pangaea broke up. As you know, there are five continents that's happening now. So the Pangaea was starting to break up, producing greenhouse gases that heated the atmosphere, causing acid rain to fall, and the oceans losing oxygen and acidifying the oceans, causing this fourth mass extinction in which 75% of the species are lost. Okay, these are some of the groups of animals that were extinct. Okay. Now, for 135 million years after the Triassic, okay, the time between Jurassic and the Cretaceous, 135 million years ago, was referred to as the age of the dinosaurs. So I think most of you have watched the film called Jurassic Park and Dinosaurs. This is the period in which it was called the age of the dinosaurs. Dinosaurs diversified, okay, dominated life on land. It was also during this time that birds and primates first appeared. Flowering plants also first appeared then. During this period, the land underwent huge changes. Plate tectonics split up Pangaea into forerunners of today's continents. Dinosaurs live in all continents, including Antarctica. They thrived very well as the conditions were very conducive during that time. But then all of a sudden, everything changed. And the most famous and well-studied fifth mass extinction happened 65 million years ago at the Cretaceous-Paleogene boundary, killing off all the dinosaurs. So what caused this? A widely accepted theory is that a very big asteroid, about 10 kilometers in diameter, landed at the Yucatan Peninsula in the Gulf of Mexico that killed off the dinosaurs. The impact ejected enormous amounts of debris into the atmosphere, causing global winter, dropping temperatures. This impact also caused devastating fires, earthquakes, tsunamis, and acid rain all across the whole world. There was also an increase in volcanic activity in the Deccan area, that is in India, around that time, which exacerbated this mass extinction that wiped off 70% of the species and wiped off the dinosaurs. Okay, I won't go into the detail of this. There were also minor mass extinctions that happened in between the major ones. Okay, there are 18 of them. Okay, but no time to go through this whole thing. Okay, so what caused these mass extinctions? Extreme rapid climate change. These are the causes. Extreme and rapid climate changes will kill animals. Right? Enormous asteroid impact. Active volcanism. Extreme and rapid air temperatures changes. Toxic atmospheric composition and atmospheric circulation changes. Very high and low water oxygen levels. Drastic sea level rise and fall. And ocean acidification. Okay, so these are the causes of extinction. All right. I'm going to end here, and I want to leave you with a question. After the fifth mass extinction, in which all the dinosaurs were wiped out, mammals thrive and diversify in what we see today. The last ice age was about 12,000 years ago, called the Holocene. And with humans occupying and dominating every corner of the earth, we can see it now, right? So are we experiencing the sixth mass extinction now? Well, many scientists agree that we are, because wherever humans settle, even before the last ice age, because humans were around, the modern one, the Homo sapiens, were around 300,000 years ago, right? Even before the last ice age, when humans settle, wherever humans settle, megafauna, these are the large-sized animals, they become extinct because of predation, that is the overkill of these animals, right? In the last 500 years, 865 species have already gone extinct. Almost 200,000 more species are threatened within extinction. Now, 500 years in geologic time is just a tiny bit, a very small bit. All right? And the rates now are much higher than the background rates, especially the last century, this 1900 until 2000. You see, the rates of extinction has gone up quite a lot. All right. So human activity may have caused it. And if a full-scale nuclear war, which we are threatened with now, with all the uneasiness going on in the world now, if a full-scale nuclear war happens, it will definitely trigger it. And the most affected species will be us humans. Right, in concluding, we just go through. There are 5 mass extinctions in the history of the Earth. mass extinctions are typically caused by a combination of natural factors, comet, asteroid impacts, widespread volcanism, climatic changes, rapid changes in geography, atmospheric and ocean conditions, or combinations of these factors. And it takes about 10 to 20 million years for biodiversity to recover after the mass extinction. The Holocene, which is about now, or the sixth mass extinction is underway. The sixth mass extinction is hastened by human activity. But we need to reduce this, we need a very complex and long-term challenge that requires the collective efforts of governments, organizations, communities, and us individuals. Okay, thank you very much for listening. Do we have time for questions? Yes? The Earth was formed 4,600 years ago, all right? And then sometime around the 4,000, then the oceans formed. When the oceans formed, life formed. At that time, the Earth was cooling, and there were small bits of land. There were small bits of land then, all right? And then when you cool more, the land became more. So there were two big ones. One is Laurasia, and the other one is Pangaea. Okay, the other one is Gondwana actually. They merge and they become Pangaea. But the Earth is dynamic. I mean, we can see today there's volcanism all over the place. There's a lot of earthquakes in Indonesia. So this is dynamism. So it's moving all the time. So we think moving that we can feel it. No, all you need is to move just 1 centimeter a year. We are talking about millions of years. Imagine 1,000,000 centimeters. It's a huge distance. So now we are now spreading out all over the place. All right? Yes, I see your hands there. Yes. Correct. If you look at the world map today, you notice that the western part of Africa and the eastern part of South America seems to fit into each other. So in between is the Atlantic Ocean. If you go down to the Atlantic Ocean right in the middle, you see a mid-Atlantic reef. And the reef is actually lava coming out, pushing the continents away. All right? Right, you're right. Because fossils found on the western part of Africa and the eastern part of South Africa, they match, including the rock formations. Okay? Any other question? Yes. A loss in both is loss in the species as well as loss in animal life. The percentages don't go very far away. So if it's 70%, it may be 65 or 75 is in between there. Okay, but most of the time we studied is species. Okay, yes, Mac. Question. Oh yes. Mac alerted me and say that right now there is a series on Netflix that is called Life on Our Planet, that is produced by Steven Spielberg. We all know Jurassic Park, all right? And it's narrated by Morgan Freeman. If you want to know more about life within these 4 billion years, have a look at this series. You learn a lot of things from there. It's very interesting. Now, I don't have time to tell you each one of them. Then you understand why, oh, now we have millions of species. So now, how come? So that series will tell you from 4,000 years until now. Okay? Any more questions? Okay, any more questions you can ask me during tea time or lunch. Okay, thank you very much.
Thank you, Mr. Keng Lok. May we invite, please, come to the stage. There will be a token of appreciation, and we'd like to invite Bapak Satriadi Gunawan will give a token of appreciation to Mensa Malaysia, Mr. Keng Lok. Thank you. Please give applause once again. Woohoo! All the guests, ladies and gentlemen.